The inverse square law of light, along with the limitations of the human eye, control all we can see. As you look at the night sky, on a clear night, you see an abundance of lights, with different colors and brightness. Light travels from the sun to each planet. Some of that light is reflected. It then travels over vast distances to Earth and your eye. Under ideal dark sky conditions, the furthest planet you can see, with the unaided eye, is the planet Uranus. It has a slight bluish or greenish hue. It's over 2,586,000,000 kilometers from Earth. The sun's light must travel over 2,872,000,000 kilometers to this planet. Then reflect from the surface, travel back to Earth, meeting the light requirements of your eyes to be able to see it. Is that possible? Our moon is stated to be about 400,000 kilometers away. On the moon, direct sunlight measures 130,000 lux. On average, it reflects 12% of that light. At 12%, the light reflected is 15,600 lux. From Earth, the light received from the moon is 0.3 to 0.5 lux. If the moon was 130 times further, it would not be visible to the naked eye. The moon will be our reference. Earth receives 130,000 lux from the sun. Given the distances of each planet, we can use the inverse square law to calculate the lux level the other planets receive. We will set Mars as reflecting 25% of visible light. All the others we set to 55. This is the amount of visible light reflected from each planet back to Earth. This is the distance it must travel to Earth, meet the requirements of your eyes, for you to see them in color, or see them at all. Uranus. The books state 49% of the light is reflected. At 55%, it is reflecting about 200 lux. To use the inverse square law for light, our first measurement should be at a distance of 10 times the diameter of the planet. Its angular size will then be about 6 degrees. In reality, the planet would be below 0.5 lux at this distance. For now, we will vastly overestimate the reading at this distance at 50 lux. Uranus to Earth distance. We can now use the onboard calculator to calculate the amount of light reaching Earth. Lux and the distance at the top. Distance between planets. With no allowance for a reduction due to the atmosphere, this is the level of visible light arriving on Earth and your eyes. With the naked eye, or even an optical telescope, your eyes would not have enough light to see anything. Yet we do. The planet Mars. Mars at its closest is 55,650,000 kilometers away from Earth. At its furthest it's 300 million kilometers. With the naked eye, we can see its light and color. Mars at its closest is over 139 times further than the Moon. At its furthest, 750 times. At Mars's stated distances, it would not be visible, let alone visible in color. It reflects less light than the Moon, and is over 139 times further away. To put this in context, a framed image of Mars with just the moonlight illuminating it. You have 1,000 times more light hitting your eye from this image, yet see no color. None of the planets would be visible. Mars, Jupiter, Saturn, Uranus, and Neptune would not send your eyes enough light to see them in color, or see them at all. They all reflect less light than the Moon. The only explanation there can be, with the color and lights we see, is that the planets are a lot closer than we're told.